Namaste one and all. So let us look at the concept, that is application of Gauss law. So you know Gauss law. Where do we use this application oriented Gauss law? Let us look what are the applications of this Gauss law. Usually it is used to find the electric field. So we can find the electric field due to uniformly charged infinite line wire, uniformly charged infinite plane sheet, and uniformly charged thin spherical charge. So let us look at one by one. So let us first consider electric field due to uniformly charged infinite line wire. So if you look over here, this is a line charge which is uniformly distributed. So in this case, what is the electric field at some distance r? So it is given by E is equal to lambda divided by 2 pi epsilon into r, where lambda is the line charge density. So lambda is the line charge density and r is the distance from the line where we are trying to calculate the electric field. So this is the equation which you need to remember. Electric field intensity due to a line wire which is uniformly distributed for infinite line will be E is equal to lambda divided by 2 pi epsilon into r. So this can also be written as E is equal to 2k lambda by r. So both are one and the same. So what I have done over here is, so you know that the value of k is 1 divided by 4 pi epsilon naught. So if I multiply 2 at the top, so 2 that will be 1 divided by 2 pi epsilon naught. So instead of writing lambda divided by 2 pi epsilon naught into r, I included the term k inside this. So that makes this as E is equal to 2k lambda by r. So this would be useful for solving the problems more quickly, since you know that the value of k is 9 into 10 to the power of 9. So whereas here we need to substitute 8.854 into 10 to the power of minus 12 for epsilon naught. So it would be difficult while calculating manually. So I included the k value so that I made some changes by including k, and I alter the equation in such a way that it would be easier for solving manually. So it is E is equal to 2k lambda by r. Now let us consider what is the electric field due to uniformly charged semicircular arc of radius r of a wire. So if the same infinite line is bent in order to form a wire, so then what would be the electric field intensity at a distance which is equal to radius of that arc? So if you look over here, so this arc has made a degree of alpha. So then what will be the electric field intensity? So it is given by electric field intensity at this location is given by 2k lambda by r into sine alpha by 2. So now you know that where k is nothing but 1 divided by 4 pi epsilon naught. So the value of k can be written as 9 into 10 to the power of 9. So the r is nothing but the radius. R is nothing but the radius. It is also equal to the distance from the point where we are calculating E to the arc, and alpha is the angle formed due to bending of this line. So it is given by 2k lambda by r sine of alpha by 2. So this is very important formula which you need to remember. So now let us consider the application of this. So if you are given a semicircle, you know that the value of alpha is pi. You just substitute the value of pi here. So that would be 2k lambda by r into sine pi by 2. So there is nothing but sine 90. You know that the value of sine 90 is 1. So electric field intensity turns out to be, electric field would be 2k lambda by r. If we consider a circle which is uniformly distributed, so you know that now the value at the center E is equal to 2k lambda by r sine, the alpha is how much? 2 pi. So if we substitute 2 pi, that turns out to be sine 180. Sine 180 is 0, so electric field intensity will be 0. So the electric field at this point will be equal to 0. So this is the important formula which you need to remember whenever a line charge is bent to form some degree alpha. So next let us consider electric field intensity due to uniformly charged infinite plane sheet. So if you consider over here, this is a sheet on which the charges is distributed uniformly. So if you are supposed to find electric field at some distance r from this sheet, it is given by E is equal to sigma divided by 2 epsilon naught, where sigma is nothing but the uniform surface charge density. So it is uniform surface charge density. If the charge is positive, then electric field will be in this direction, that is normal to the surface pointing towards or outside the surface towards right. If the charge is negative, it will be pointing inwards. Okay, it will be pointing inwards, or it is nothing but it is pointing towards the left. So this is regarding the sheet charge. Next, let us consider the electric field due to spherical charge. So this is not circle, this is a sphere, and the sphere with the radius of r. If the charge is uniformly distributed over the sphere, then we need to calculate the electric field outside the shell. If we consider the electric field outside the shell, that is the distance is greater than the radius of this sphere, then the electric field intensity is given by q divided by 4 pi epsilon into r, where q is the charge which is nothing but the which is total charge which is present over the surface, and r is the distance from the center to the point where we are trying to find the electric field. And the electric field inside the shell, when the value of r, that is the electric field intensity where we are calculating, if it is less than the cap letter r, that is it is we are trying to calculate electric field within the sphere, then its value would be 0. So this is regarding the applications of Gauss law. I hope you have understood this concept clearly. Thank you for watching the video. I hope you have understood the concept. So to know whether you have understood the concepts better, you need to answer the quiz. The link for the quiz is given in the description below. After answering the quiz, you will be getting the result. So retake the quiz until you find that you have answered all the answers correctly and got the complete out of out results.